Hello everybody, welcome back to the live stream. So today we will be learning data structures and STL in C++. So, data structures is a common topic. We'll see how we can use those concepts and try to do it using STL. So STL is exclusive to C++. So let's see. Uh, so about data structures. Data structures are used to store and organize data. All right. Um, so that's a data structure. An array is an example of a data structure which allows multiple elements to be stored in a single variable. All right. We know about array. C++ includes many other data structures as well. Each is used to handle data in different ways. These are part of the C++ STL, which stands for Standard Template Library. And why we are doing this is there is also C++ classes, but let's look at that later because if we cover this, we can solve some more problems. So that's why let's complete this first. All right, so STL is a library that consists of different data structures and algorithms to effectively store and manipulate data. All right. If we say that data structures store data, we can say that algorithms are used to solve different problems, often by searching through and manipulating those data structures. All right. So algorithms and data structures are different, right? Data structures are objects that we use to store data or things that we use to store data, but algorithms are different methods, right? We can use to solve problems using that data, right? So using the right data structure and algorithm makes your program run faster, especially when working with lots of data. The most common data structures, all right. So we know about vectors, right? Vector stores elements like an array, but can dynamically change in size. That is the advantage of a vector. Adding and removing of elements are usually done at the end. Elements can be accessed by index. List is there, stores elements sequentially, where each element is connected to the next. Adding and removing of elements can be done at both ends, not accessible by index. There is stack here. So how is vector and list different, right? How are they different here? If you see, adding and removing elements can be done only usually done only at the end, right? Here in a vector. But in a list, they can be added, at both ends. So, and the main difference is in vector, you can access this by index, right? Access the elements by index. On a list, you cannot access the elements by the index. All right. So that was about vector and list. In stack, when you come to stack, stores elements in a specific order called LIFO, last in, first out, where elements can be only added uh, and removed from the top, not accessible by index. All right. So if you look at here in a stack, it's like you say stack of books, right? You keep it one on top of each other or one on top of other, right? So when you remove the book, you remove the topmost book, right? So at that menu, place it back also, you know, that book which you removed goes on top first. So last in, first out, right? So the last one that you put, the last book that you placed comes out first, right? When you take it out. So that's what is a stack. And a stack of books is the best example for a stack. And a queue stores elements in a specific order called FIFO, first in, first out. So when elements are added at the end, where elements are added at the end and removed from the front, not accessible by index. So here, whatever like comes first goes out first, right? Um, like how you would be standing in a line, right? Uh, the first person gets the higher priority that is on the line, right? So that is a queue. Um, DQ stores elements in a double-ended queue where elements can be added and removed from both ends. Elements, so this is like a double-ended, right? You can add an element at both ends, right? So add or remove from both ends. Set stores elements, stores unique elements. Did you notice the difference here between stack and queue and then DQ? Stack and queue, you cannot access elements by their index, right? Both stack and queue cannot access element by index, but with DQ, you can access the elements by the index. So that's an important difference. Set, when it comes to set, stores unique elements, all right. So there cannot be duplicate elements here. Again, not accessible by index. When it comes to map, stores elements in key value pairs. We will look at this later. This is very important actually. Map we have to use this in many areas when it comes to solving the problems. So they like it stores elements in key value pairs accessible by keys, not by index, right? So you have, for example, if I go here, um, so it's going to be like if I have, say, there is key here, there is key, all right. On one side there is key, on the other side there is value, right? So if you look at it this way, and if you take an example, right? So key value, right? And if you have, let's say, books in a library, right? So you have the title of a book, right? Title of a book. So here, let's say the key is a title, or for example, let's not take that, okay? Let's take a different example. Let's say the key is one, okay? One, two, three. Let's say these are serial numbers, you know, serial numbers one, two, three. And in one, what is stored in one, in one, for example, person A, person A, in one person A is stored. Let's denote PA. And in two, person B is stored. Name of person B is stored. So like this, it keeps going, right? So like this, as key and values, we can store how much ever we want. And depending on whatever, suppose if I want to access this value, I can just refer to this key number 2 and then I can access it, right? So I don't have to remember all these values, right? I can just have these keys and then I can just access this, right? So that is about map. So everything is mapped to a value, right? Um, and here vector, this is how it is accessed, right? Using these libraries. Um, and you have, all right, so here, that was the introduction. Um, okay, this we know already how to create a vector and everything. All right, so let's see. The key components of STL consist of containers, iterators, and algorithms. All right. Containers are data structures that provides a way to store data, like vector. Okay. Iterators are objects used to access the elements. All right. And then algorithms include functions like sort, find, that perform operations on data structures through iterators. All right. Data structures and algorithms go hand in hand. Data structure is not worth much if you cannot search it or manipulate it efficiently using algorithms. So yeah, and okay. So let's see the first topic, vectors. Okay, so there is vectors here. All right, so let's see the first data structure, which is the vectors. Vector in C++ is like a resizable array. Both vectors and arrays are data structures. This is over multiple elements of the same data type. Difference between an array and a vector is that the size of an array cannot be modified. You cannot add or remove elements from an array. However, vector can grow or shrink in size as needed. So yeah, so that's the thing. How to create a vector, we already know here how to create the vector. So you have to say vector and then in angle brackets you say the type and and then you provide a variable name for the vector, right? um, and if you want to add elements at the time of declaration, place them in a comma separated list inside curly braces, just like with arrays. So this is how you can do that. All right. The type of vector string in our example cannot be changed after it is declared. Okay. All right. Access a vector. You can access a vector by referring to the index number. All right. So zero indexed meaning that is the first element, one is the second element, and so on. So starts from zero, keeps going. All right. Yeah. So if you want to access Volvo, you say cars and then square bracket zero. Yeah, most of this we have already done, but let's see what's new. Using the vector library, okay, advantage. I think from here it is like we're going to learn some new things. Okay, it includes many useful functions here. You can access the first or the last element of a vector with the dot front and dot back function. So this is a STL feature that we have not learned. Let's see how we can do that. So dot front. Using the dot front, you can get this element, the first one. Of course, you can also do it using this, right? Uh, but it's just easier to, say dot front or dot back than, you know, when in sometimes you don't know, right? Like, for example, say like you don't know what is going to be, right? So in that case, you can just say dot front and dot back, and then like you can just leave it there. So let's see how we are able to do that. Um, let's see. Um, okay, let's just name this stl.cpp, stl.cpp, and then I'm going to say um hashtag hash include, and then iostream, and I'll just include vectors, and using namespace. By the way, if you're new, if you have just come to know about this channel, please do consider subscribing. Um, if you like this live stream, uh, and yeah, also like the video. And after this, I'm just going to say int main. If you are not able to understand any of the things what I am writing, please go back, not right now, but later when you have time, go back and watch my older videos, so older live streams, so that you are able to understand all these basic things. So let me just, now I have to create a vector. So, right, so let me just say vector, and then it's string type. So string, and then name of the vector, I'm just going to say vector string, name of the vector, I'm just going to say cars, and then this is how you store, right? Volvo, BMW, Mercedes, Mercedes, Ferrari, whatever you can write. Lambo, Lamborghini, Lamborghini, and you can just keep adding whatever, how much ever you need. Um, we have an error here. Let's see. Okay, these are strings, right? So we need to include them in this double quotes. So do not forget that. Do not forget it to keep it in double quotes. So let us just do that. And I'm just going to put it in double quotes here. All right, so now we are good. Think so, right? Something is still not what happened here. I think we are good though. Um, why am I getting an error over here? Are you able to find out? Okay, here we have two double quotes. I think we are good now. All right, so now I want to access the first element here. So I'm just going to say cout, and then cast dot first. I think that is the word. cars dot front. All right, not first. Cars dot front, and then see out also cars dot back. Cars dot back. So this should be printing. This should be printing first Volvo and then Lamborghini. Let us see if that happens. All right. Let us also give a slash n here and make sure it prints in the next line. I hope that is good enough. Let's see. Or endl is also fine, but let's see if this works. I'm just going to change the name stl.exe. All right. And then let's see. All right. So it's compiling. Compiled now. Um, STL again. Okay, so that didn't work. Let's see. Of course, the program worked, but the slash n. Um, let's see. Okay, that's an error. All right, let's use endl itself. It's yeah. So let's just use endl then. All right, now we got the output. All right, Volvo is the first front element and Lambo is the back element. All right, so that is done. And also here, if you see, um, when you're accessing a vector, right, here, sometimes this changes, right? This vector can change. So sometimes, you know, the size can change, right? So you might say, why not? Let's just use this, right? Let's just access the elements using the index, right? We can do that here too by saying like, okay, cars 0, cars, this should be cars 3, right? Um, but that's not possible because sometimes this is dynamic, right? This can change, right? So how will you know what is the last element, right? We don't know, right? So how can you refer that using the index? So that's why we need this cars dot back, right? So that's why. Um, so you can also access an element at a specified index. So that can also be done using this dot add function and specify the index number. That is also possible using dot add. Um, and yeah, so this is how I can do this. Dot add is also can be used. Um, here if you go, for example, and then I'll just drop an handle there. Um, see out cars dot add, and then I'm going to say first index. First index is BMW, should print BMW, right? So let's see if it prints BMW. Yeah, so it printed BMW, which is at the first index, right? Volvo is at zeroth index, BMW is the first index. So that's how you can use that function. And the next thing is you have change a vector element. All right. To change the value of a specific element, you can refer to the index number. Okay, so you can change it using this, right? So for example, if I have to change this Mercedes to maybe, let's say, Audi. Okay, so let's change Mercedes to Audi. By the way, don't, you know, do that in real life, because sometimes Mercedes, almost all the time Mercedes cars are better. So um, don't do that. But let's do it here. Um, okay, so let's do it here. See, I'm just going to say cars, cars of, it is the second index, so second, and then I'm going to call this like Audi. This is now updated value. And now when I access that element again using cout, now when I access this, let me just comment this part out. I'm just going to comment all these. All right. So now cout cars 2. Now it's going to print Audi, right? Now it's going to print Audi. So let's see Audi. So I'm not saying all, by the way, like I did say Mercedes in general is better than Audi, but I'm not saying all their cars are better. Some Audi cars are good actually. So let's not take that in a, you know, absolute sense. Okay. Anyway, let's just keep going. Um, all right. So that was how you can change, right? Change the elements, change the value of the first element. You can use this as well, dot add to change. And then here you have to actually, yeah, you have this important, you know, function called pushback, right? To actually add the elements at the end. So if you want to add an element, for example, I want to add an element to this array, I mean, to this vector. So I can just say cout, or I can just say here cars dot pushback, use this pushback, and then the element I want to add, right? Whatever element I want to add. So I'm just going to say, I'm going to add what is another. Okay, so let's just say Tesla, then Tesla itself. So Tesla, so I'm going to add Tesla here. And now when I see out, now I've added Tesla, right? Now when I see out this vector itself, see out cars itself, right? Um, all right. What happened there? Why am I not able to? Okay, now let us just access it using the index otherwise. Um, let us see what is at the last thread, because this goes to the last thread. So let us see cars dot back, right? Cars dot back, that should return Tesla, right? So let's see if that happens. Cars dot back, comment this out as well. Cars dot back should return Tesla now. So let's see. Yeah, so Tesla. So we have just added this Tesla to the last, right? To the last index, right? So that is possible using pushback. So similarly, you can add how much ever elements you want, right? It just keeps adding, you know, in order. Um, to remove, we can use the pop back dot pop back function, which removes the element from the end. So now if I just say pop back, right? Pop underscore back. So I'm just going to do cars dot pop back. So it's just going to remove Tesla, right? See out, see out, right? See out. Can I access it? So there is nothing in the last element right now. I mean, now the last element would be what? Lamborghini, right? Back to Lamborghini as the last element. So now let's see. Cars dot back. Cars dot cars dot back should return Lamborghini. So let's see. Because we removed the last element, which was Tesla before. Alright. Tesla and Lamborghini is printed. Okay, why is that? Okay, so let's just remove this. We also printed it here, right? So let's just remove that, comment it out. So here we are pushing back Tesla and then here we are popping back Tesla. So now we should be good. Let's see. Yeah, now the last element is Lamborghini. All right. So that was about push and pop, push back and pop back. Elements are usually only added and removed from the end of the vector. If you need to add or remove elements from both ends, it is often better to use DQ instead of a vector. Alright, so that is clear. Vector size, find out how many elements a vector has. Use the size function, dot size function. Alright. So you can just retrieve the size of this, obviously, using dot size. So what is the size of this vector? Here we can just say cout cars dot size function, and then that is going to return the size, right? I have not saved, I guess. Let me just save it. All right. Now run it again. So Lamborghini over here. Okay, let me just remove that. Let me just comment this as well. Let me just comment it out. Now, now let me just do it. So size is 6. All right. Why is it 6? Because we did comment it out here, right? The pushback we just commented out. The pop back we just commented it out. So now what happened? We have this pushback, right? So Tesla is added at the end, and with Tesla the size is 6, right? So when you count 1, 2, 3, 4, 5, and then Tesla is also there, there is 6 elements, so size is 6. All right, so that was about size. Check if a vector is empty. So is the dot empty? So if it is empty, right? So cars dot empty outputs 1 if the vector is empty, else it's going to output 0. So let's just check that. This is actually quite helpful in solving a few problems later. So let's just check here. See out cars dot I'm just going to say is empty, or just say empty, right? Not is empty. Let's say empty, empty, right? Now, because it is not empty, it is going to return 1. So let's see, because it is not empty, right? So let's see now. Why did it? Okay, all right. All right, all right. Let me just remove this. Let me just comment this out. Um, because this size thing is also getting printed. All right. All right. So now for empty, it's going to print 0. If it is empty, it's going to print 0, right? Sorry. Okay. So if it is empty, it's going to print 1. So 1 is false, 0 is true, right? So if you see here, if you see here, no. Actually, if like, okay, 1 is true only. So we are checking, right? If it is empty. So if it is empty, then it is a positive, right? So that is true. So it's going to return 1. Else, if it is not empty, it's going to return 0. So let's check that. So let's see. So now it's returning 0 because it is not empty, right? So let me just make it empty now. I'm just going to make it empty. I don't even need this actually. Let me just have that, and also comment this as well, right? This line too, right? So let me do that too. And now let's see. Now it is empty. So let's see. So now it's going to return 1 because it became empty, right? It's nothing is there. So yeah, can check if it is empty. Loop through a vector. All right, so this is how you can loop through a vector. So this is going to print all these elements, right? This is how you can loop through a vector. Goes from 0, 0th index, right? Dot size, you know, it just changes dynamically, right? How much ever you add, that much times it has to loop, right? So you can loop through the elements, and yep, this slash and make sure, it goes to the next line after every element is printed. You can also use the for each loop here. Yeah, because if you don't need the index, there is no use of the index, then like you can just use the for each loop this way. That is also going to print the elements. So that was it. I think this is about vectors, right? So that much. Yeah. So I think that was about vectors. I think there is. Yeah. So this is more like a revision. We already know a little bit about vectors. So yeah, we'll have to we'll have to look at other things as well. So yeah, let's do it in the next upcoming live streams. So yeah, I think that is good enough for today. Um, let's see if there is any questions or anybody was here. Otherwise, let's end the session. So yeah, I don't think there is any questions. So I think we'll end the session here. So let's, yeah, so I'll I'll see you in the next live stream. Um, until then, see you and bye. So yeah, thanks for watching.